Okay, so we'll observe that a non-trivial proper subspace of R3 is either a line or a plane. We also know that the rank plus the nullity of a linear transformation is equal to the dimension of the space that we're transforming. So if you got a transformation from V to W, N is the dimension of V. Rank plus the nullity is the dimension of your V space if you're mapping from V to W. What's rank? Rank is the dimension of your row space, which is also the same as the dimension of your column space. The nullity is the dimension of your kernel or null space. Okay, so if you have a transformation T of V equals AV, where A is a 3 by 3 matrix, then that transformation can be taken as a transformation from R3 to R3. Okay? So that would be a T from V to W, where V equals R3 and W equals R3. Well, in that case, the dimension of V is 3. The dimension of R3 is 3. And any basis of R3 has 3 vectors. That's what it means to be a basis. The rank plus a nullity has to equal 3 then. Okay? Well, the rank is the dimension of your column space, row or column space. The nullity is the dimension of your null space. So, what's your picture? What's the geometry associated with this transformation? Well, if the nullity is 1, then the dimension of your null space is 1. Your null space is just a set of multiples of a single vector, which means everything is on a line. Then we say the kernel or null space, I'm going to say is a line. It really isn't a line, but it's identified with a line. It's a set of vectors, which and it's a line through the origin, okay? Set of vectors identified with a line through the origin, initial point on the origin and terminal point at some point on the line. Okay? What's the rank? Well, the rank plus the nullity has to be 3. The nullity is 1. Then the rank is 2. So the row space, which is in V, is spanned by 2 vectors. So it's a plane. Through the origin. Okay? So we can attempt to sketch that. Okay? The nullity is 1, so the null space is a line through the origin. Okay, so let's just say the null space is a line through the origin. Now we don't know if that line comes out this way or goes back that way. And, you know, why don't I just, I can find my purple chalk, color code this like I did before. So here's some line through the origin. This is your null space. Your column space is going to be spanned by 2 vectors, okay? So You can have a vector here and a vector here. Okay. Well, a column space is going to consist of all vectors that can be obtained as a sum of multiples of these vectors. So your column space is a plane, and I'm not going to attempt a really great picture of a plane, but let's just say that here's the plane. I'm not doing anything to indicate an orientation here. It's more a schematic diagram than anything. Okay, well, if the plane, let's say, has this direction, then the null space has some other direction. Okay, row space is the plane, null space is a line. The line is perpendicular to the plane, which means that maybe the line passes through the plane at this point, and that we use kind of a dotted line on the other side. That's a little smudgy. I can't do much about that. You can imagine that this null space line could be perpendicular to this plane. Okay, maybe the plane's like this and the null space is like this. It is true, it can be proven in general. So that's kind of a bad picture, but we get the idea. Now we have, this is the space V. The null space lives in V because it's a set of all vectors in V that map to 0. Your W vector, your W space is over here. And once more, your entire null space goes to the origin. I'm not going to draw a bunch of arrows. And your column space, not sure, yeah, this is supposed to be an arrow here, isn't it? Will be another plane, maybe oriented something like this. Goes through the origin. The way I've drawn it, it doesn't really much look that way. But the row space and the column space can map onto each other, okay? Your transformation, since the nullity is 1, it's not an invertible. Your matrix A is not invertible, but there is an invertible transformation between the row space and the column space because they have the same dimension. Okay, so the column space is here. You have the rest of W. There's a lot of W that's not on this plane, and of course the null space maps to the origin. So this whole V here maps onto just this plane. There's a whole lot of W that's not part of this plane, but there's no vector in V that'll map onto any vector in W other than this plane. So the whole three-dimensional space collapses down to a column space. And it collapses along the direction of this null space. Okay, so that if you have a vector, or point out here, so you have a vector kind of similar to the way we drew a vector before, out to some point that's not in the plane, not in the row space, well, you can follow that vector along parallel to the null space until you hit the row space. So you're going to have a vector here in the row space. This vector is in the plane. This vector is perpendicular to the plane. So this will be your Vn, which of course can also be written or drawn over here. So once more, the vector V, call this vector V, we can write exactly the same expressions that we wrote previously. Okay? The only thing that this depends on is that t of Vn be 0 and the linearity of t. So you can look back at the other equation. It applies in this situation. It applies in any dimension. Okay, so that's a picture of the transformation. And then, of course, if I extend this line here, it's a line parallel to the null space. Okay? Every vector on this line goes to the same point. So that if VR goes to here, this is your image of VR. Here. Then every point along this line will go to that same point. Okay. Now there's another related picture. If the nullity is 2, then the kernel is a plane. Okay? So now this purple plane could represent your null space, and the yellow line could represent your row space. Okay? And your column space would just be a line. Okay, so I want to sketch that, but I'm going to sketch that off camera, and then we'll come back and see what that might look like.